Okay, so here is a problem that may be a little bit different than what you see in a standard parallel slash series resistor problem. So let's kind of piece this together, kind of take it apart. Remember, the end goal here is to get this to look like one big super resistor. So you're going to have your power source here. We set it at 120 volts, and we're going to want to combine all of these resistors into a, a, a single resistor such that it looks like this. And then it's a little bit easier to figure out information such as the current that's flowing through this. And then remember, we'll call this our equivalent resistance. So what you want to do is try and work with the most complex piece first. And then within that set, you want to try and determine if you see pieces that are in series or in parallel. So the first thing I'm going to do is I'm going to look at this pair right here, and I'm going to notice that they appear to be in series. Now remember, circuits are in series when relative to the other circuit, the current has no way, but one way of flowing. So we'll get current that flows in this direction initially, and then it's going to flow here to this point, this junction point, and then it's going to have an option of branching out. But just take it one step at a time here. I would say look at that piece first. And so what we'll get as a result is we'll get this 8 ohm resistor. It'll stay. We'll get that these two resistors combine to make a 12 ohm resistor. So we'll just set it up as such. We'll have that 5 ohm there, and then we'll have this resistor crossing through still at 4 ohms. Now, what you'll notice here is that these two, the 4 ohm and the 12 ohm resistors, share this point and this point in common. So probably an easier way of looking at that would be to see that we could write this 12 ohm resistor in its spot, and we can still write this 8 ohm resistor as such. But this 4 ohm resistor, notice again, common junction point. So that current that goes through that area is going to be the same at this point and at this point. And so we can say that we'll have a 12 ohm and a 4 ohm resistor here. And here's our 5 ohm resistor. Okay. And that's 8 ohms, obviously. And so piecing this together one more time, we can see now that these two resistors are now in parallel with one another. You can um, kind of see that at this junction point here, that there's an option in terms of sort of the splitting off process, the direction that the current can go, right? And likewise here. So the current can either go in this direction or it can flow in that direction there. So we'll say that these two resistors are in parallel with one another. Now do this only one piece at a time. It'll make it a lot easier for you. So let's draw the new resistor in red this time. So what the equivalent resistance for those two would be, so we'd have 1 over the equivalent resistance. We'll call it equivalent resistance 1, because our end goal is REQ, is going to equal to 1 over 12 plus 1 over 4. And so what you're going to get out of this is, let's see, we can cross multiply and get 12. Cross multiply, add that with 4, multiply those two. So this is 16 over 48. Therefore, REQ1 is to flip the inverse of that. And so that would be equal to 48 over 16, or 3 ohms of resistance. And so that would be our new resistor for those two. So mesh those two together and create a new resistor here of 3 ohms. We'd still have our, let's see, we'd still have our 5 ohm resistor, which is here. And then that ties in with the 8 ohm resistor, which runs in this direction here. That 5 ohm resistor. And so relative to these 3 points, it looks like these 3 all have, well, actually these 2 points, the current has only one way to go. And so we would say that we can combine those two using our sum of 2 resistors. So those two are in series. And so we would write just those two as an 8 ohm resistor. It's 8, the other 8 ohm resistor still remains. So this one stays over here and this one is over here. Bad picture for that resistor, but I think you kind of get the point. And then finally, we can see that the current, again, relative to this junction, has multiple ways of deviating. So we can see that these two are parallel to one another. And so we would say that the new resistor would look something like this. Calculate. And typically, you know, when you start doing a bunch of these, you'll see that the sum of these together is going to equal to half of the total resistance. But let's do it again. So 1 over REQ, we'll call it 2, or actually that's just going to be REQ, is going to equal to 1 over 8 plus 1 over 8. So that's 2/8, or 1/4. And so REQ, which is what we want to get to, is equal, has a resistance of 4 ohms. So there we have it. We've reduced this down to a single equivalent resistor. And now you can figure out the current that's going through here. So the current relative to that box, that power source at that point would be 120 volts divided by the 4 ohms. And so it would be 30 ohms, or 30 amps, sorry. Okay, so hopefully that helps you out. Just do it piece by piece. Realize where your junctions are. Like this one might be a little bit confusing in that you might place it at this position. That's a common mistake, but just realize that the junction comes after this, if you will, this resistor. So it's the same thing as writing and drawing the resistor sort of so that they look parallel is probably the key to solving that. All right.